So today we're with Chris, who works at Leica, and he has brought a very special piece of technology that I've just been oogling over for many, many years here. As you know, we like to recreate like digital environments in many ways. Sometimes we'll take like an HDR scan of an environment to project lighting and materials and reflections onto digital characters. Other times, like in anime self-driving cars, we'll like photo scan an entire environment with like a drone and stitch all the photos together and map it out to create a virtual environment. But Chris here has brought a special tool that can kind of do all that in one.
So this is the Leica BLK360. It's a 3D scanner using LiDAR. It's also got HDR imagery capabilities. Typically used more in the construction space and capturing 3D scenes, but to a couple millimeter accuracy. But now we're starting to get into getting some traction in the visual effects industry, and that's why we kind of teamed up with you guys to try and check out some of those workflows. Yeah.
What's the big difference though between using this and that? Because they're both 360. Sure. We'll both get like 360 images from it.
Sure.
But what is the main difference with this and that?
I mean, the big difference is we're actually using LiDAR. So we're actually using a laser to collect measured points to create a 3D model, actually, a 3D point cloud.
How does LiDAR work?
So LiDAR is using a laser from the inside. As you can see here, the laser's on the inside and it hits this mirror, this 45-degree angle mirror. Then that mirror spins and it shoots out a laser point, and using time of flight technology, it's bouncing back and takes a measured data point. And so the data itself is actually scaled. But because of that, as this rotates, then this whole thing spins. You've got a single laser beam kind of going like this, and then it rotates 180 degrees. But then you're collecting, full 360 because you're capturing that slice all at once.
Is there a camera on this as well then somewhere?
So, yeah, there actually is. There's 3 cameras right here. So as it goes around, it's first stage it goes around, each one takes a snapshot. If you got the HDR turned on, it's 3-stage, so each one will fire off at 3 different lighting settings, and then as that goes around, it does 10 stops, so you essentially end up with 30 photos that are stitched together into one like total of 150 megapixel image.
Okay, I noticed that the spinning laser, it's kind of interesting because I'm familiar with like the Vive trackers, like the lighthouses.
Sure. And
I know they use a similar system, and when you see those little like boxes up on the walls, they actually have a similar system as far as having a spinning synchronized laser that helps detect like the IR signals from the actual Vive headset.
Oh, sure.
So it's actually kind of like a similar mechanism, but for different uses.
Yeah. So from a single location, when it shoots out, it's got a maximum range of 60 meters, so about 200 feet. So that's in full 360. Essentially, the only kind of blind spot is pretty much the footprint of the actual tripod right here.
So our goal for today is to photo scan our studio and the loading dock, and basically get a 3D model and a digital recreation of our entire workspace for their use.
Wow.
Yeah, it's gonna be pretty sweet. Do you want to actually go to the loading dock first and start there? So, because I think that we can get some really good explanation and context of the just really what makes this special versus our current process.
Sure.
Cool. Okay, so here in our loading dock, I can give you guys the best example of why this technology is really special to us. When we filmed our Boston Dynamics video, in order to get that robot looking like it's naturally in the scene, we would take our Insta360 cameras and we would scan a 360 HDR of this environment. And that image allows us to separate the bright points from the dark points and light our scene. So if you look around here, you can see there's like some lights there, we got some lights up here, and it's able to tell us where our light sources are coming from. However, there was one small issue that led us to have to redo that lighting. And here's kind of how that works. So when you scan a 360 HDR of an environment, you're getting a giant sphere. That's what your image ends up looking like. You get a sphere that surrounds your environment. The problem though is that that sphere, it's not in 3 dimensions here, it's in 2. Imagine I'm inside a sphere here of light, but the problem is that when you scan it in 2 dimensions, that light sphere has to kind of move with you because it's at an infinite distance. It doesn't actually move with your scene or anything like that. So when you have an issue like this, where you have a scene that has a single top light, when you scan your HDR, whenever the character is standing directly beneath the light, it's going to look completely natural. But suddenly, if the character steps in 3D space away from it, that 360 HDR, it's not going to move away. It's going to stick with your scene. So when it came time to render that video and light it and do all that stuff, we had to go through and in 3 dimensions put light sources back where they were. So that made it so we couldn't like actually rely on just our image map to recreate the scene. However, when you start using this and you have the LiDAR that actually scans your environment in 3 dimensions, you can feasibly have a fully functioning 3D lighting environment that allows any characters to walk around in it and have the light sources react appropriately. It's a long-winded explanation, but I feel like that's as concise as I can possibly make it. Your lights stick where they need to be. Great to do like the HDR scan because I'm okay with the extra data because we can definitely use it.
Sure.
So loading dock's done. We're gonna start our, we're gonna chart our course from the loading dock back into the studio.
Oh, these are all the scan ports?
Yeah. So the scan's done. How many scans was that? Like we went through the loading dock, through the hallway, studio, and a couple of the cool rooms here.
Yeah, so we did about 13, 14 scans.
Oh my gosh.
Here's an example of a top-down view of the scans we've taken. These chunks, this chunk over here is one bundle that's all been together, and I've got two other scans that have not been registered yet. So all I have to do, I know this was over in front of the Airsoft stuff, so if I just hit this link, press this scan right here, we've now got this top down just between these two, and we'll hit optimize and just see it snaps them together. We hit create link. So we'll do that one more time with this scan over here, just get it close to where it should be, say hey register with that one, hit optimize, and it snaps it together.
Oh my god.
Create link.
That's so stupidly easy looking. Oh my gosh, because like each one of these files though is like super dense. There's like millions of points. Like they have to be huge file sizes. How the heck does this like work so quickly to align that stuff? How do we get there? Because this is a lot of data.
Dude, what?
This is a lot of data. Look at this. Like this is crazy.
So again, this is just kind of like low res preview of the data. This will be all a lot more solid, but it also kind of like a almost a little X-ray view
So
kind
fun
of thing.
to just like
Yeah.
float around and see.
Yeah. Oh my god, that's so cool.
Yeah. And you can change it obviously in units and stuff, but anything you can see on here, you can just pull a measurement on. You can
I wonder if
zoom
this is
in
a
on it.
construction.
Yeah.
Exactly, and that's
awesome.
like I said, that's what it's
so
kind of made
cool.
for. But so many other applications you can.
Jeez.
I just like how it's accurate. Like that idea of accuracy and like bringing a lot of the guesswork out of it is so cool.
Absolutely. Well, cool guys.
Yeah,
Appreciate
well,
it.
yeah, man. Thank you so much for coming by, making the time to come out here.
Yeah.
I know you have a packed schedule showing.
Sure.
Everyone wants to see this.
Yeah, right.
So I'm really glad we got to do this, and hopefully we can get this out to you guys, so that way you can take a look and see what our studio's like without having to fly out here.